The other method, there it is, hunting for it, is to take your equation and convert it to this form, and then just use your transformations to determine what the asymptote is. Okay? We do that by doing something weird, adding 0. Okay? Which sounds weird. I'll show you how that works. So if we take this function, y equals, what was it, 4x minus 5 over x minus 4, you'll notice it's not in this form, right? But we can turn it into that form by adding 0. Okay? Here's how that's done.
I think it's minus 2.
Is it minus 2? Oh, thank you. That will help me. Here's how that's done. Okay. What you want to do here is you want to add a 0 term so that you're able to factor 4x and that term you added so that you can cancel the x minus 2. And if that didn't make sense, I'll show you what I mean. Okay. If I took this expression on the top, 4x, and I had a minus 8, notice how that would factor into x minus 2. Right? It would cancel eventually the x minus 2 on the bottom. Okay? So, I know I want to minus 8 in the top here so that I can get this factored form and cancel my denominator. Since I'm minusing 8, I also have to plus 8. I'm essentially adding 0. These things together just equals 0. So I'm not changing the value of the function. I'm just changing its appearance so that the factoring works out nicely. Okay? And if you're still not with me, I'll show you how that all magically works in the end. Okay? So, but I just want to make clear that the reason why I'm going minus 8 plus 8 here is because I want eventually this expression.
What happened to 5?
Okay? It's still there. The 5 is still there.
Oh,
okay? And then all of this is still over x minus 2. Notice the difference from what I started with to what I have now. I added 0 here in the form of minus 8 plus 8.
So it could be anything?
It could be anything.
Which one is 16 plus 16?
It could be. But you want to choose what that is based on how you want this right here to factor so that you have this as one of your factors. Because notice what I have now, right? I have, if I factor just this part, I have 4x minus, if I factor it, there we go, 4x minus 2, and then this part here becomes just 3, all over x minus 2. Okay? Let me finish it up so you can see how that works.
So that's the next step?
Yeah, that would be the next step. I'm going to split the fraction now so that this numerator and this numerator have their own separate denominator. I'm just splitting the fraction in 2 pieces here. Okay, plus 3 over x minus 2. And we're almost home. Because I have this factor now, it will cancel. And I end up with this. 4 plus 3 over x minus 2. Okay, and if I reverse those, then I have a transformed format, right? Where it looks like this guy up here. A is 3, H is 2, K is 4. So you can kind of tell here what happened to the asymptotes from the function y equals 1 over x, right? The vertical was moved 2 to the right. The horizontal was moved 4 up. And if you remember from last time, we said that the horizontal asymptote was y equals 4. So that communicates the same thing here, right? So I know it's a little bit awkward, but the key is deciding what you want 0 to look like here. You want to choose your value for 0, or what you're going to plus and minus, so that you can get a factor up here that matches something down here. Okay, I'll do another example to show you how that works again. So if we take the other function, 2x plus 2 over x minus 4, right? I'm going to have 2x minus something plus something plus 2 up top over x minus 4. And I want to make sure that this part right here, you guys see this part right here? I want to make sure that whatever I choose for this number right here, I can factor it so that I have 2 times x minus 4. So what number should I put here so that when I factor this whole thing, I get this? 8. Again.
Well, actually, if you just took the 2x minus 4, couldn't you just factor back in and go what you wanted?
Say that again?
If you took the 2 and then x minus 4, couldn't you just put the 2 back in and get the number you wanted?
Yep, you can do that. Yeah, you can say, okay, I want it to look like this, so if I just multiply that 2 in, that reveals the number that you should plus and minus. So if I chose 8, if you factored that, would you get the green? You would, right? If you chose something like 4 and factored it, would you get the green? No, right? So you want to choose that number so that when you factor it, you get something that has a factor equal to the denominator.
Oh.
Right? Because the goal here is to cancel that denominator in one of your terms. Okay, so we plus and minus 8, and we get 2 times x minus 4 plus 10, all over x minus 4. And then split the fraction again. Okay, so then I end up with 2 plus 10 over x minus 4. And switching those around. What is my horizontal asymptote on that basis?
Minus 4.
Compared to this function. It used to be y equals 0. How is it translated?
Y equals 4.
It was moved 2 up.
Oh.
Right? This thing moved it 2 up. So the horizontal asymptote should be y equals 2. And again, if you remember from the last time we did it, that's what we got.